Let's hack the Windows computer. So on the left we have the box, a Kali Linux computer, and on the right we have a Windows computer. Now I can show you the details of that computer. If I right click here on properties, you'll see it's Windows 7 Ultimate from 2009. And on the right we have Kali Linux system. So let me just enlarge this font here to make it more readable. So this is Kali Linux, a Linux distribution specifically for hacking. So what we'll do is we'll compromise the Windows computer. And the way we'll do that is using a malicious program, a bad program, so-called malware. We'll create the malware, and when the user runs that malware, we will take over the computer. Now, the thing to note is that in the Windows firewall settings, there is no Windows firewall is turned off. It's not turned on, because that might actually block our attack. So we turned it off. And what we'll do is create a malicious program using the command line here, using a tool called MSF Venom, Metasploit Venom. So it's a command line program, and we need to tell this program can create malicious or malware programs. Now, we need to specify the target platform. So in this case, we want to attack a Windows computer. MSF Venom supports many different platforms. You can attack Apple computers, Windows computers, Linux computers, Android, and so on. So in this case, we'll specify Windows and want a shell. So we type shell_reverse TCP. Then what we want the program to do is to give access to our computer. So we type lhost, specify that it connects to our computer, and then we need to specify the network address or the internet address of our computer. Now we can get that using another command with the command IPAS. So if you type that command, you'll see devices, the loopback device, which you can ignore, and you'll see you have a network device here with this address. So the address has 4 dots in between and 4 numbers. You can copy that address. You'll see it shows in purple, and we just paste it in here. Then we specify the communication line, call a port. Now that port can be any number, but in this case we'll go with 443. Then the file format. So every system has a different file format for runnable programs. On Windows, that is .exe. On Mac, that's DMG. On Android, that's APK. And such files are file types that can be executed, can be run as programs. For example, if we go to the Windows 3, you can see a program. For example, we see here, we have a program here, WordPad. If we right click on it, properties, you'll see it has a .exe extension. So in this case, we want to create a .exe file, because that's the Windows executable. Then finally, we want to give a file name to our program. So I'm going to call it game.exe. Now that's going to take a moment to execute. Remember, I turned the firewall is not on this Windows computer. Now that's going to take a moment to generate, and you'll see once it's completed, it says the final size of the file is this or that amount of bytes. And the file is created in the default home directory. So on the Kali Linux computer, we have the malware program now. So the next thing to do is to get that malicious program onto the Windows computer. Now there are various ways that you might do that. Maybe you can send it via an instant messenger program. You can send a download link. That's another way. Or can also give a USB flash with that malicious file. There's different ways that the victim could get that file on the computer, maybe by email. We can upload this malicious file. If you go on the internet, there's many sites where you can upload files. So if you search on the internet for uploading files, there's many sites where you can upload the file and then you can again download them. Okay, so once the file has been transferred to this computer, so in this directory I have this malicious file downloaded from the internet, from an internet link. We need to actually start a listener before we can attack, because what this program does is starts a reverse shell. That means that the victim connects to your computer. That's why you had to specify your internet address. So you need to start a listener, and you can do that with this command. So now you'll see it's listening, and once the user starts this program, you'll see we instantly have access into the Windows computer. It says here Microsoft Windows, copyright, Microsoft Windows, and so on. And now you can type Windows commands. You can completely control the computer using those commands. For example, we can type dir. You'll see we are in the downloads directory, and we see the file here. We can delete files. We can go into different directories and so on. We have basic access into the Windows computer just because the user started a malicious program. Now let's say the firewall is actually on this Windows computer. We start a listener on the computer, and then we try to run the same program. Go to the downloads directory and we click on that program. You'll see the firewall is running here, and we can now double click, and you'll see we're still connected to the computer. That's because the way this works is using a reverse shell. So the program that we run actually connects to our computer. So we have an outgoing connection, and the firewalls typically block incoming connections. So the other way around. And so this method can be used to bypass a firewall, at least for the Windows 7. You can see here the firewall is running. So it only blocks the other way around for the connection. Let me just clear this. So start a listener, and then if the program is started, you still see this little thing, but that's not a firewall. If they click run, you'll see we're in the Windows computer despite the firewall being run. Now, newer versions of Windows, they actually check for malicious programs. Before, they have some antivirus stuff and other things. But for the Windows 7 platform and older, firewall doesn't necessarily block the malicious program. So in this case, the firewall is really running. You'll see it notifies when a firewall blocks a program, and it's blocking incoming connections, but this program is actually an outgoing connection. So if I clear the screen here, you'll remember that we run the command, and what it does, the program connects to our computer, providing it's called a reverse shell. So it's not connecting to the Windows computer, but the Windows computer is connecting to us. That's why we can block, why the firewall doesn't detect our program. And so we actually start the listener on this computer, and it's a reverse shell. The malicious program is not an incoming connection, but an outgoing connection. You'll see, even if we click this, blocking all incoming connections, and we run the program, we still get access into the computer. That's because the program is using an outgoing connection, not an incoming connection. It connects to our computer, so-called reverse shell. Whereas if we were to directly connect to the computer, that's a regular shell or bind shell. But the reverse shell, the Windows computer connects to our computer. That's why we start this listener here, so that it can connect to our computer. Now, one thing to note is that we are on the same network. We're not on a different network. Otherwise, you would have to use an internet address in order to be able to connect to the. So both computers are on the same network for this to work. You can get more information about the system using this command line. For example, if you type the system info command, you can find information about installed updates, which version of Windows is running, and so on. Because here it says we are running Microsoft Windows, but you don't know that much about the target yet, just that it's a Windows computer. So if you type system info, it will tell you additional information about the target, such as it's running Windows 7 Ultimate in this case. If it were another version, you would see that. So the build version, not that useful, but you can find different information when it was installed, who is the company owning this product, and so on. So very basic information, something about the memory. And also you might see updates if they are installed. You can also see running services if you use the net start command. So if you type net space start and press enter, you'll see all the running services on the computer. So you'll see we type the net start and all the programs that are running in the background, the system programs. You'll see different things here. So you'll see it's running Windows Defender, Windows Firewall, Windows Search, Windows Updates, and all the system programs that are running. You can see those with the command net start. If you want to know which computer programs are installed, you can type another command, which is wmic product get name version number, name version vendor. So if you type that command and press enter, it should tell you which programs are installed onto the computer. So in this case, there's not any new programs installed. You can also list the installed updates, again using wmic. So using this command, you can see the installed updates, if any, and in this case there's no updates installed. Which is quite obvious because when you type the system info command, it gives you all the system information, and if any updates or patches have been installed, you'll see that listed in here. So in this case there is no system information or installed updates onto this system. So on the left we are listening for a connection on our attack box, and a user can start this program. That can be a regular user, but it might also be an administrator. So if it is an administrator starting this program, you immediately have administrator access into the computer. But it might as well be a regular user, in which case you cannot completely access all of the computer's files. So to see which type of user you are, you can type the command who am I, and that will tell you your username on the computer. So very basic commands, but it doesn't tell you what you as a user can do. So in order to see that, you can type who am I with an additional flag, the /priv flag. So if you type that command, it will tell you what you can do on that computer. For example, it tells her we can shut down the computer if we want to and do some other things. Now users are always part of groups, can be the administrator group or another type of group. So to see which groups you are part of, you can type who am I /groups. And if you type the /groups command, it will tell you which groups you are part of. So in this case, we are part of the home users groups, but also of the administrator groups. So we're actually an administrator user who started this program. If I check that in the control panel here, and go to users, user accounts, you'll see we are part of the administrator group. We're an administrator user. If we weren't, you wouldn't see the administrators listed here. So you can find basic information about your user using these commands. Any type of user can start the program, so it can be an administrator starting this program, or it can be just a regular user. In the case of a regular user, you wouldn't have, for example, the privilege to shut down the computer. Or perhaps you would have, but maybe not some other permissions. If the user starts the malicious program, it gives you access into the computer. But maybe you're interested in some more information, like which other computers are on the same network as your victim's computer. So which other computers are on the same network? You can do that with the command arp-a. That will tell you about other devices. Other can be computers, can be printers, or whichever devices on the same network. So arp-a tells you about which other computers are on that network. So you'll see that these are the internet addresses of on that network. You might be interested in what is your own address, that you can see with the command ipconfig. So if you type ipconfig, you can see your own address, in this case 107. It says here IP version 4 address, that's the internet address. And you'll see 107 is not listed here because it's our own. You'll see our interface 107. So there is another computer on this device and also a router here, .1 are usually routers. You can find out more about which other machines or network connected machines are connected to that computer. Now, you might be interested in which programs are running that have network connections. You can see that with command netstat. That tells you about which programs have an internet connection. So in this case, one program running, which has a network connection. Of course, that is our malicious program, the game.exe that we are running, that gives us access into the computer. But it might be that there are other programs running that allow you to connect to the computer. For example, maybe screen share, remote desktop protocol. Maybe there's file sharing. If you share a folder, then you might see another network connection there. So you can find different connections using the netstat command that will show you which addresses it's connected to. Or local address, and it's connecting to a Linux in this case. Because the program, of course, it connects to our computer. The reverse shell it creates is a very basic shell. We have the reverse shell where we can browse around the file system, delete files, and run some commands. But for example, we can't take screenshots of the desktop or download files or upload files. So in order to do that, you need another kind of shell. We'll create the interpreter shell. So we type msfvenom, and all the commands the same, except for one thing. Instead of the payload shell reverse TCP, we'll create another payload, which will be the interpreter shell. Now, it's important, if you have a 64-bit Windows computer as the target, you type x64, otherwise just leave that out. So x64/ or just slash if it's 32-bit. You type interpreter and then reverse HTTP. So in case you want to know, you can go to the computer here, right click properties. You'll see this is a 32-bit version, so it doesn't need 64 here. So we press enter, and that creates a new executable for targeting, but instead of the default reverse TCP shell, it will use the interpreter shell, which is more advanced, has more features. So now we need to copy this file, game.exe, onto the Windows computer. Once you have copied the malicious executable to the Windows computer, we need to start a listener, just like with the other. We need to start a listener just as with the other shell. So in order to do that, we type msf console, the Metasploit console. Now it takes a moment to load that console, and then we'll type use exploit multi-handler. You can use tab to type the whole thing. Then we set our IP address, lhost. We set the listening port, that is the same. Set the payload. Now if you use a Windows 64-bit computer, type x64, otherwise leave that out. And then type exploit. So now it's waiting for a connection, and if we start the program, run it, you'll see we now have the interpreter shell. It says here interpreter, and we can type commands. For example, if we type help, see we can type all kind of different commands, word database commands. You scroll up, you'll see there's different categories. You can play audio, you can record the webcam or start a video chat, list webcams. You can do things with the user interface. For example, take a screenshot, share the actual desktop, so what the user is currently doing, just watch what you're doing, and control the mouse and do other things. So user interface commands. You can do some system commands. You might restart the computer or close a program and things like that. There's networking commands. You can find out about the network. File system commands. So now you're able to download files and also upload files. And you can do many other file system commands. You'll see also some core commands. So let's do some of these commands. For example, we type screenshot. That will take a screenshot of the victim's computer. You'll see it saves this in the default Kali directory. If I open the folder, you'll see it took a screenshot here. We can download and upload files. So if we check the current directory, you'll see we're in the downloads directory. Maybe we're interested in downloading a file. So we type download. We can also upload files. So if we create some file, we can upload that. For example, we upload it to the... Okay. Let's go to the desktop directory and upload that file. You'll see now it uploaded that file onto the victim's computer. You can do all kind of things with files. Basically, you have complete control over the computer with the interpreter shell. And if you type help, you can see all of the commands that you can do. So it is more advanced than the reverse TCP shell, which allows you to browse around the file system and run commands. But it doesn't have advanced features like taking screenshots, recording the desktop, and the others. We'll crack those passwords. Now, for this to work, first we need to remember that we specified a certain payload. So this payload. Now remember, if you have a 64-bit computer instead of a 32-bit, which is most computers these days, or almost all, specify the x64 parameter in there. This is our IP address and port, so you'll need this information later. So we'll start a program called MSF console as a listener. The program will connect to our computer and we need to have a listener. So we type MSF console. That will take a moment to start the console. And now we type some commands. So we set a handler. Then we set our IP address, which is the same one as in our command line program. We set the port, which is also the same as our command line port. And we set the payload. The payload is the same as our command line program as well. Now remember, if you have 64 bits, add the x64 / there. Then we press exploit. Now instead of running this program as a regular user, the victim will run it as administrator. Now that is important because that way we will be able to dump the passwords. So if you type help here, you'll see we can dump the passwords, but that only works if the victim run the program as administrator. So we can type the command #dump, and you'll see that dumps the passwords, and the passwords are actually in the last parameter. So you'll see several values here which are separated by a colon. We have the administrator user, Alice, a user called computer, guest, different users, and the last parameter, which is actually the password. So we can copy this hash. It's a hash. It's the way passwords are stored in a cryptic format. We copy it. We go to the internet here and we open a website called crackstation.net. Then we paste it in, click not a robot and click crack hashes. And now we found the password for the user Alice. We can do that also for the other user. So we have, for example, here the user computer. The last parameter here is the password in a cryptic format, and we can crack it. If you right click copy, we go to crackstation, go to crackstation.net, we paste our password hash, click crack hashes. And you'll see that cracked the password for this user. So if the user picked a very strong password, this won't actually work, but it's using a password cracking database, which is quite large. You'll see 15 billion passwords. So it's very probable you can crack one or more passwords on this computer using this method. It's very important here that the program is actually run as administrator. So if you don't do that, if you run the listener and then run it as a regular user and then try to dump the password, you see that is actually not allowed. Operation failed. That is because this needs to be run as administrator. So if you have the listener as administrator, if you run it as administrator, you'll see if you type #dump, it will dump the passwords, and that only works if the program has been started as administrator. Then you see all those values with the users on the computer, and the last value, or actually the fourth value, because there's possibility for more values there, the fourth value. If you copy that, you can crack the actual password hash. So let's see, let's try this one. Maybe we can crack that or not. Copy it and we'll paste it in. You'll see in this case the password was not found. So sometimes you'll have luck and sometimes not, depending on whether the password is in this 15 billion database. But this is how you can crack those passwords. So you need several things to happen. The program needs to run as administrator, and then you need to copy the password hash, the cryptic word, to crackstation.net in order to crack it. Now the first thing we need to do is to get initial access into the computer. That's as a regular user. And there are many ways to do this, but for this example, we'll just create a malicious bash script, that the user downloads and installs. So you can do that on Kali Linux with a tool called MSF Venom that can create malicious scripts and malicious programs. And okay, so we can start MSF Venom. That tool is a command line tool, command line program. And when you use that program, it can create malicious scripts, malicious payloads. You'll see payload generator. And the way it works is by typing the MSF Venom command, then what type of shell you want. So we want a reverse shell, then your computer address, the format, and the file name. So let's actually create a malicious program. So we type msfvenom -p, where we specify the payload. We'll use the reverse netcat payload. Then we need to specify what computer the victim needs to connect to. So we'll use our computer. And in order to do that, we need to know our computer's IP address, which we can see with the command ipaddr_show. So if you type ipaddr_show, it shows your IP address in purple. Now I'm gonna assume the target and the victim, or the attacker and the victim, are both on the same computer network. So we type the same IP address as shown here. So ipaddr_show shows you your IP address. Then a port. And finally, we need to specify the output format. So I'm gonna name it teams.sh, or whatever the user will run by accident. Now that takes a moment to create a malicious program. That really can take a moment, but not too long, like maybe 30 seconds, depending on the payload. You'll see it created a new file, teams.sh, containing the malicious script. So you can actually output that or take a look at that file. You'll see this is the actual script. So what we want to do next is to get that script to the user's computer. It might be through a USB drive, or maybe a web page where the user downloads that script and runs it. Now, one thing you'll note is that we specified our computer address here. That's because what we want to do is to make the victim connect to our computer. So we need to start a listener. We need to start listening for a connection on our computer. And we can do that using a tool called netcat. So netcat with the port 4444 or 444, which is the same port as we specified here. We make the computer or the victim connect to our computer because usually victims have a firewall installed blocking incoming connections, but they almost never block outgoing connections. So that's why we make it connect to our computer. So we start a listener. Then the user downloaded the teams.sh file and makes it executable, runs it. You'll see when we run the script as a user, we don't really see anything special. It seems that it's just connected. However, when we actually look at our netcat listener, we are able to type now commands because we received a connection. You see connection to this computer. So we can say, who am I? Or what's the current directory? Into a certain file. And we can access the computer completely and browse around. And we have a very basic shell, but a very primitive shell. So what usually happens is that instead of a netcat shell, they'll create a bash shell, which is more easy to work with. But the main idea is that the user starts listening. The hacker starts listening for a connection. The user runs the malicious script. Once the malicious script is run, there is an actual shell that the hacker can then use and can type all kinds of commands in the victim's computer. You'll notice that we have a Kali Linux and we're inside the computer. It's just that this shell is a bit inconvenient to work with. So what you can do is, as a hacker, is to create another kind of shell, bash shell, where it's much easier to work with. In the previous video, you saw that we could create a malicious script using a program called msfvenom. So by using msfvenom, we could create our malicious script that once run gave us access into the victim's computer. So we started a listener on our computer using netcat on port 444. And once the user started the script, we got access into the computer, giving us a dump shell in the victim's computer. So we could now type commands inside the victim's computer, and it shows the output. So in this case, we're user Frank, which is obviously this computer and not the Kali computer. You might output certain files. So if we run this command, we can see that victim is running Ubuntu Linux. It shows some more information. So we can type a lot of commands to get more information on the system, and also to gain complete access into the system, so that we have the administrator password, the root password, and other users and their passwords. So you'll learn how to do that in this course, and you'll also learn many commands that will help you get more information about the system. So for now, you can use this simple shell, and later you'll be able to maybe get the passwords out of it and use SSH or another service to a more stable shell into the victim's computer. So one of the things you'll notice about this shell is that you cannot press Ctrl+C or have a history or such kind of things, but you can run commands on the victim's computer. So for example, we can type ls/etc and it shows you the files in the etc directory, or you can output certain files with the cat command. You can say cat etc password, and it shows you the users and other information on the computer. So using the cat command, you can output any file, and we have very basic access into the victim's computer as a regular user, in this case user Frank. So of course that will depend on which user you are, but in the next videos you will learn post exploitation, how you might get passwords from all of the users, how you can get all kind of other information about which other computers are on the network, on the same network as the victim's computer, as well as other information. So we're really focused on the post exploitation step, and also be able to crack the passwords if there's a misconfiguration. So that's what we'll get into. So gaining initial access into a Linux computer, you'll usually have a shell, typically the bash shell. Now, commands provide information on more than one area. So you can get system information, information on users, networking, and running services. For example, we may want to find out which type of Linux system is being used. So we can say that we can see that in a file called /etc/os-release. If you output that file, it will tell you the Linux system that is being used. So in this case, I'm using Kali Linux. Now let's try that on another Linux system. So we'll type the same commands. Let me enlarge this terminal here. So we output the file etc/os-release, and you'll see this Linux system is a Ubuntu system. It shows the version number as well, the code name, and also some side information. So on any system, you can find the Linux system you're using by outputting this file. You can find the system's name by typing the command hostname. You see in this case it's computer. Now let's try that on the other computer. We type hostname. You'll see it says hostname Kali. Now on Linux there's many files that provide interesting information. For example, the files etc password, etc group, and etc shadow. We can try to output any of those files. So we might try etc group first. And this will tell you users on the system and which groups they belong to. For example, here we have the user scanner belonging to the group Saint and Kali. If we scroll up, you can see different users and the groups they belong to. So here's a user and the group it belongs to. So that's the file etc group. Now let's take a look at the file etc password. So that contains all the users on the system, contains their password, but their password is stored in another file called etc shadow. The user ID, some description it can contain, which is where the files of the user are stored, so in this case /home/Kali, and which type of shell they use. Take a look at that at the other computer. So we take a look at etc group, and you'll see different users on the system, some groups here, LP admin, user, and the group Frank, group Saint D, and so on. So that's etc group. Now etc password is more interesting. That contains the users on the system. So for example, here we have system user Ubuntu, the user ID group ID, where the users files are stored. In this case for user Ubuntu, files are stored in home Ubuntu, and is using the bash shell. And you can see other users as well. And a very interesting file is the file etc shadow. So if I try to output that, you'll see permission denied by default is where the passwords of all the users on the system are stored. So let me output that, open that as a administrator user by typing sudo in front. When you press enter, you'll see username and the password for that user. It's written between the colons. And if you scroll up, you can also see the root user also has a password. You'll see some of these users don't have a password, and that's because they cannot log in. You'll see they don't have any shell here after that. And we can see the same in etc password. So some users don't have any possibility. For example, here we have the user sane_d, and the shell is no login. User pulse, and the shell is no login. So those users are system users. They cannot actually log into the system. So all those no login users means that they cannot log in. They are just system users. So let's go back to etc shadow. We output it, and you'll see users have a certain password, and this password is stored in a hash format. That means that even if we have access to this file, we cannot directly read the passwords. If you want the passwords, you'll actually have to crack it. So it's a technique to obfuscate the passwords, but this actually contains the passwords of the user Kali. Some other useful information we found in the directory var mail. So there's a directory on any Linux system var mail, and if it's a server, might have some information on the system and on the users. If you are using a Debian-based system, so you can see that with OS release. In this case, it's a Debian-based system. We're using Kali Linux. So if it's a Debian-based system, you can find a list of all the installed packages by typing the command dpkg-l, and that will show you all of the packages installed onto the Linux system. With space, you can navigate to the installed packages. So that's dpkg-l. Let's say you have initial access to our computer, a Linux computer. So in this case, we're inside a Ubuntu Linux computer. We can get the version using OS release. So you'll see we are inside the Ubuntu computer. And what you can try to do is to elevate your privileges. So to get the passwords of other users. Might be the password of the root user or password of other users. So how can we do that? One way to do that is using those files I showed you before. So the etc password file and the etc shadow file. If you can access those files, then you can actually crack the passwords for all of the users in the Linux system. So what you can try to do is to connect to the computer and then just download the password file and the shadow file. You don't actually need the groups file. So I'm going to the etc directory, download the password file and the shadow file. You'll see I was able to access both files. I can also show you that. I can type cat etc shadow and it will show you the contents of that file. So the file is readable, which is a misconfiguration on the server. So if that's the case, then you can download both files onto your computer. And you'll see I have both files here on the computer. Next, we'll combine them using a tool called unshadow. And let me close the little window behind the screen. So unshadow, password, and shadow. And that will save into a combined file. And I'll call it #2crack.txt. So now we have a combined file that combined the contents of the first file and the second file into another file that has all of the data combined, so the passwords and the other information. So here you'll see there, after the second column, there's a password. It's a hashed password, so you can't actually read it, which is why we need to crack it. Some of them have an asterisk here, that means there is no password. If you scroll down, you'll see some other users here, Ubuntu with an asterisk, so with a colon and another password here, and Alice with another password. So that's command, just created a combined file. Next, we can crack that file using a tool called John the Ripper to crack passwords. So what we can do is type John, then we need to use a word list to actually crack a password. So there's a word list included by default in user share word lists. So I'm gonna copy that file. You'll see there's a word list here that ends with GZ. That means it's compressed. We need to extract it. So we're going to paste it here, extract it. Now, it can take a moment. It's quite a large word list. It's a word list of millions of commonly used passwords. So we can specify the word list now. So word list is rocu.txt. Then the file we want to crack and the format we want to use. So in Linux, the format we want to use is usually the format crypt. So this is the basic command to crack the password using a word list. Now, it's very important that the passwords are in the word list. So if the password is not found, that means you need a larger word list. You can find many password lists on the internet, and this just specifies the Linux format. So if you press enter, you'll see it starts cracking the passwords, and it outputs the passwords for all of the users and passwords on that computer. So you'll see the usernames here, Ubuntu, root, and Alice are the users on that system. And you also see the passwords here. So now we know all of the users and all of the passwords on this Ubuntu system, and you can then take advantage of that. So, for example, let's say we want to be the root user, and we can type to root, and now we know the password of root, which is root. And you'll see now we are the root user. We can go in the root directory, for example, list files, or do anything, because root is the administrator of the system. We can also access a specific user, for example, Alice. We can say su Alice or su Ubuntu. So we can, let's see, password Ubuntu is Ubuntu. We can now access all of the users and all of the users' files. We cracked all of the users and passwords using this. Now, for all of this to work, it is very important that the shadow file is readable, that there is a misconfiguration. So if we type here cat etc shadow, in our case it outputs the entire file. The file is readable. Let's see, it's readable by the user. It has the R permission here. So if the file is not readable, what you'll actually see is permission denied. So in that case, this technique doesn't work. So in order to crack the passwords, we need to be able to access the shadow file. But if you have access to that file, you can then crack the passwords and have all of the usernames and passwords on the system. After gaining initial access into a Linux computer, you'll usually have a shell, typically the bash shell. Now, commands provide information for more than one area. So you can get system information, information on users, networking, and running services. For example, we may want to find out which type of Linux system is being used. So we can say that we can see that in a file called /etc/os-release. If you output that file, it will tell you the Linux system that is being used. So in this case, I'm using Kali Linux. Now let's try that on another Linux system. So we'll type the same command. Let me enlarge this terminal here. So we output the file etc/os-release, and you'll see this Linux system is a Ubuntu system. It shows the version number as well, the code name, and also some site information. So on any system, you can find the Linux system you're using by outputting this file. You can find the system's name by typing the command hostname. See, in this case it's computer. Now let's try that on the other computer. We type hostname. You'll see it says hostname Kali. Now on Linux there's many files that provide interesting information. For example, the files etc password, etc group, and etc shadow. We can try to output any of those files. So we might try etc group first. And this will tell you users on the system and which groups they belong to. For example, here we have the user scanner belonging to the group Saint and Kali. If we scroll up, you can see different users and the groups they belong to. So here is a user and the group it belongs to. So that's the file etc group. Now let's take a look at the file etc password. So that contains all the users on the system, contains their password, but their password is stored in another file called etc shadow. The user ID, some description it can contain, which is where the files of the user are stored. So in this case /home/Kali. and which type of shell they use. Take a look at that at the other computer. So we take a look at etc group, and you'll see different users on the system, some groups here, LP admin, user, and the group Frank, group Saint D, and so on. So that's etc group. Now etc password is more interesting. That contains the users on the system. So for example, here we have system user Ubuntu, the user ID group ID, where the users files are stored. In this case for user Ubuntu, files are stored in home Ubuntu and is using the bash shell. And you can see other users as well. And a very interesting file is the file etc shadow. So if I try to output that, you'll see permission denied by default is where the passwords of all the users on the system are stored. So let me output that, open that as an administrator user by typing sudo in front. When you press enter, you'll see username and the password for that user. It's written between the colons. And if you scroll up, you can also see the root user also has a password. You'll see some of these users don't have a password, and that's because they cannot log in. You'll see they don't have any shell here after that. And we can see the same in etc password. So some users don't have any possibility. For example, here we have the user Saint D, and the shell is no login. User Pulse, and the shell is no login. So those users are system users. They cannot actually log into the system. So all those no login users means that they cannot log in. They are just system users. So let's go back to etc shadow. We output it, and you'll see users have a certain password, and this password is stored in a hash format. That means that even if we have access to this file, we cannot directly read the passwords. If you want the passwords, you'll actually have to crack it. So it's a technique to escape the passwords, but this actually contains the passwords of the user Kali. Some other useful information we found in the directory var mail. So there's a directory on any Linux system var mail, and if it's a server, might have some information on the system and on the users. If you are using a Debian-based system, so you can see that with OS release. In this case, it's a Debian-based system. We're using Kali Linux. So if it's a Debian-based system, you can find a list of all the installed packages by typing the command dpkg-l, and that will show you all of the packages installed onto the Linux system. With space you can navigate to the installed packages. So that's dpkg-l. You may be interested in getting network information out of your Linux system. You can do that by typing the command ip space address space show. So ip space address space show. And if you type that command, it will tell you the network devices. So in this case, there's one network device, ETH0. LO stands for loopback device. That's a software-based device. So ETH0 in this case is the device. And it tells the network device address. So the address on the network of that device. Now, it's quite a lot of typing. So what you can do instead is type ip space a space s, which does exactly the same, but you have to type less keys. So that will tell you the IP address of the computer, the internet address, or the local network address. Now, there's an older command called ifconfig. So ifconfig -a might show you that information as well. So you'll see ifconfig -a shows you the information. Now, this is an older command, so it might not work on all Linux systems anymore. If you type this command or IP address show, you can find the IP address or the network address of the computer. So this is the network address. The other is a loopback address. So if you see 127.0.0.1, that's not an address that actually exists on the network. And this address actually exists. So that's how you could connect it to the same network. To see which programs are listening on the computer, we can use a program called netstat. So we can run it as root. Or we have to run it as root. We type netstat -plt. We want to know the ports listening. So we type plt. And you'll see there's not any ports listening on this computer. Now, of course, we can use a program called enlightening. So we can run it as root. We type netstat -plt. We want to know the ports listening on this computer. make the computer listen on any of the ports. So we can say, we can start a program here. Let's say we listen on port 4444, run it again, and you'll see, hey, there's a program running on program listening for a connection on the port 4444. And the program shows you actually netcat or nc. So with this command, you can see which programs are listening for network connections. Now, a more advanced way to check, a more complete way to check, is using the command atupn. That listens for all type of connections. So lossless and not lossless connections, TCP and UDP connections. So that shows you more information. In this case, you'll see there's a program called Network Manager that's listening on port 68. And so you can find different information on programs listening on your computer. Now another tool you can use to check for services is a tool called nmap. So if we have the IP address and we type nmap with that IP address, so IPS shows the IP address or the network address, and we actually scan that computer, it will look for open or services, programs that are running that accept network connections. So if we open some program that is for a connection, and we actually scan that computer, you'll see it found that the port was open. It was listening for a connection. And so using nmap as well, you can check for services that are running. Now that is useful because there might be some services running that you can connect to further exploit your access into the system. It might be that it's running a backdoor or some other kind of software in the background that you can take advantage of. Now you might be interested in other computers on the same network. So if you have initial access into the computer and you know that the network address, you can try to find other computers or other devices in the same network using a tool called ARP scan. So sudo ARP scan with the IP address. And if there are other computers on the network, it will report on those computers. So you can then try to gain access into those computers using the access into this computer in order to further increase your access into the network. The network access, so there might be multiple computers in the same network or multiple devices. And using access into one computer, you can try to gain more access into other computers, more access into the network. Now, it can be useful to find which processes are running in the system. So the command ps lets you show or discover all the processes information on the system. So there might be a lot of different programs running in the background, and ps-e will select all the processes. So you can type ps-e and press enter, and it will tell you all the processes that are running. So if you scroll up here on this very long list, you'll see process ID, the terminal they are running on, the time, and the command. So the command is actually the most interesting because it tells you which command or which program is actually running. And usually the process ID is useful as well because you use the process ID to, for example, stop a program. And so you'll see those are related. So if you scroll here, you'll see, for example, here we have the program SSH agent, and that has the process ID of 1447. And if you scroll down, you'll see another program, shell, and it has the process ID of 1777. So that's how you can list all of the processes on the system. Now there's different formatting you can use. For example, you can use ps-el, L for long format. So that gives you more information. It tells you more information on the process, or you can use the -f for the full format, where you also see, if you use -ef, you can see the user that started the program, the process ID, and also the commands that's running. So you can see all of the commands, and you'll see some of these programs have been started as root, as administrator, and others have been started as the user Kali. For example, we have qterminal here, which is this little terminal, has been started as user Kali, whereas program udisks-d has been started by the user root. So you can see for all of the programs which user is running it, or which user started it, and what is the command they use to start it. So this ps-ef shows you the or the full list format, which is more useful if you want to know that. So let's actually start a program. So we start a listener onto this computer. Open a new window. And let's say we start some program, so netcat and listening on a certain port, and see if we can find it. So we're gonna, now of course you can start any kind of program. I just start this program as a malicious example where we start a listener on the computer. Then we run the command ps-ef, so showing the long format, and press enter. And you'll see the user Kali started this program. So you can find all of the programs that the user is running. And you'll see that this is actually a combination of the user root and Kali and whichever users are there. So you might be interested in a specific user. If that's the case, you can use a pipe and then type grep Kali and press enter. Then you'll see all the programs that the user Kali is running. So quite a lot of programs. And in here we see the program it started, this listener. And in this case, if we scroll up, you can use the idea to actually stop the program. So if you want to stop it, you can type kill -9 and then the process ID. Oh, sorry, that's the other one, 7048. And press enter. Let's list the processes again. And you'll see it actually stopped the process, even though we still see some output here. Let me close this terminal and start, for example, calculator. So we started a simple calculator program. We list the processes. You'll see the calculator is running here, and we try to kill it. So you'll see the process has now been killed using the process ID. We didn't use the name of the program, but we used its ID. So if you want to know about the processes, just type s-e or -ef. For a specific user, you can type ~grep with a username. That shows you the processes of that specific user. So that can be Kali, it can be root, or whichever user you're interested in.